recording. All right, good. So yesterday, just to do a recap, yesterday we discussed about measures like descriptive statistics, whereby under descriptive statistics we talked about measures of central tendency, and we exhausted all the measures of central tendency, that is mean, mode, and median. Okay, and we started also the measures of variability, that is uh, variance and standard deviation. But we did not discuss about standard deviation. We were to start that today. So for variance, of course, we discussed that in length, and we saw that variance basically shows us how our data points are spread away from the mean, or are distributed away from the that is away from the mean. Allow me to just admit. Okay, right. Okay, so today I want us now to discuss on that is standard deviation itself. And remember that we said standard deviation, it is the square root of variance. We said standard deviation is the square root of variance. Okay, and we have population. Of course, we said we have population variance, and also we have sample variance, whereby under population variance we said it is square root, that is of it is sigma squared, sorry, and for sample variance we said it is s squared. Now we need population what? Population standard what? Standard deviation. So population standard deviation, it's basically square root of what? It is square root of variance. So it will be square root of variance. Sorry. It is square root of variance. Okay, whereby we know it is now sigma. So it will be sigma alone. Okay, then also we need sample, that is sample standard deviation. Sample standard deviation. For sample standard deviation now will be square root of s squared, which is what? Which is s. So this is our what? This is our sample standard deviation. This is our population standard deviation. Okay. All right. And we also said about standard deviation mostly helps us to know the risk of an investment, or to know the rate of return of an investment, okay, of a given period of time. So at least that is its application in what? In finance. Otherwise, let's now do some deep dive, and that is a standard deviation. So standard deviation, of course, it is a statistic that measures the dispersion of a data set relative to its mean, and it is calculated as the square root of what? Variance. So, of course, it is a measure, a statistical measure of dispersion. Dispersion majorly meaning variability. Okay, how our data points are varying, okay, from one point to the other. And then we have also said that um, it is calculated as the square root of what? Variance. We had already indicated that. Then also the standard deviation is calculated as the square root of variance by determining each data point deviation relative to the what? To the mean. So it's like what we had discussed yesterday. That is, of course, variance. Let me assume we are talking about sample variance. We say that by definition, sample variance is given by summation, okay, from I, that is I equal to 1 up to n, okay, of the xi's values minus the standard that is minus the mean or minus the sample mean, okay, squared, and then you divide by what? Then you divide by the total number of observations. That is the sample size. So this is what? This is the sample variance. Okay, and we are talking about now the standard deviation. So we are saying that it is calculated as the square root of variance by determining each data point deviation. So you can see this, that is, this one shows us this one shows us the what? The difference. Okay, this shows us the deviation. That is the data points deviation. All right. Yeah. So basically now if we want the standard deviation out of the variance, we'll just move forward and do what? Do a square root. If we do a square root now, we will have obtained what? That is standard deviation depending with this definition. All right. Also, if the data points are further from the mean, definitely the standard deviation will be what? Will be higher. If the data points, let's assume we have our mean here, this is our mean, and then the data points are far away from the what? Uh, far away from the mean. Okay, of course the standard deviation will be what? Will be high. But if the data points are that is are close to the what? Are close to the mean, okay, then we will get what? Then we will get that is a smaller what? A smaller standard deviation value. Okay, that's okay. So if the data points are that is are further from the mean, there is a higher deviation within the data science. That is within the data set. That's the more spread out the data, the higher the standard deviation. The more that is our data it's spread away from the mean, then of course we will have a higher what? We'll have a higher standard deviation. That's okay. I think I was clear under standard deviation. Unless maybe you have a question under standard deviation. Anyone who has maybe some questions under the standard deviation, or some points to add under standard deviation before we can go to just that is some of the takeaways of standard deviation. All right.
Uh,
Yes,
uh,
sorry.
just I want to just ask do are we at some point going to do this practically
Of
or
course.
just okay?
Yeah, of course we are going to do this using Excel. We will do using Excel functions. Yeah. That is, in fact, after next week on Monday, we will have to first of all do practical of whatever we've covered. that is on Monday, because tomorrow we usually don't have classes. So from Monday we will we will be having a practical session. I will share the data set with you over the weekend. Yeah, but after every topic there is a practical session. We must have a practical session. Okay, any other maybe question? All right, so we can now go to the takeaways. Um, Maybe before we can go takeaway, I think I had shared my mode of training. I usually prefer we first of all understand the concept. Okay, what are we really talking about? Because we can't go straight to the practical, and maybe you don't have a background information. That's why I usually take a topic first of all. We discuss that topic, and then we do the practical. And during the practicals, definitely I will be posing some questions, okay, to see what if you understood throughout the theory part, okay. Yeah, so if maybe I find there exists a knowledge gap, then I also explain more as we do what? As we do the practicals. So that has been my that is model or mode of training, and I usually assume it is the best. Yeah. So let's now go to the takeaways. So under takeaways, standard deviation measures the dispersion of a data set relative to its mean. That is, it of course, because it is a measure of dispersion or measure of variability. And it is calculated by taking the square root of variance, very correct. And standard deviation in finance is often used to measure the relative riskness of an asset. Yes, it will give you the risk of investing in what? In a certain asset. Why? Because that is assets or asset portfolio which usually have high, the one which has high standard deviation. It's mostly or it is most of the time considered as what? As the riskiest maybe portfolio. So with that, at least you can be able to see your portfolio. If your portfolio uh, of course has an accumulative standard deviation which is high, then it means you are putting your eggs in what? All your eggs in one bucket, okay, which is risky. So the knowledge of standard deviation sometimes help us in something we call diversification, okay. Diversification meaning like you have that is a different you invest in different assets which react differently, okay, to that is to some factors which might impact positively and negatively to an asset. Yeah, so it helps us more so to that is assess the risk of maybe an asset which we need to invest in, and with that, definitely you will be able to diversify if you see a risk, okay. Yes. So we usually say that a volatile stock has high standard deviation. Of course, volatility that is meaning high risk, okay. That's why we usually say in finance one characteristic of shares, they are highly volatile, Okay, yeah, they are highly volatile, meaning their standard deviation it's quite high, and it is risk. Okay, it is risk at the same time, depending with what, with your risk appetite. If you are a risk averse person, then definitely you will go for diversification. Okay, meaning you fear risk. Okay, you fear to take risk. All right. So a volatile stock has high standard deviation, while the standard deviation of a stable blue chip stock is usually rather low. That is blue chip here stock. It is basically used as an index. Okay, it is a benchmark. We are trying to assume that is a blue chip always have a stable what? Always has a stable maybe stock price. All right. So as a downside, the standard deviation calculates all uncertainty as risk, even when it is in investors' favor, such as above average returns. Yes, of course, standard deviation takes like it calculates risk. Okay, even if it is in the investors favor, it is also risk. Like for example, if we have high volatility in shares, okay, remember that the shares, even if they are highly risky, they might be performing very well. Okay, meaning the share prices are what? Are going up, okay, compared to the price which you had bought. Like for example, um, if maybe you had bought a share, one share at 20 shillings, okay, and the share is what? It's the share price it's increasing towards 80 bob. Okay, of course the risk is high, but it is in your favor, because in this case you will enjoy what? You will enjoy profit. But let's assume when maybe you bought shares at 20 shillings, okay, and then maybe that is the share price is depreciating to almost 5 shillings. Okay, of course this is what? This is a loss, and it is triggered by the high volatility. Okay, that is high volatility characteristic of what? Of the shares. So meaning here in this case, you will what? You will be losing. Okay, you will be losing. That's why we are saying that the downside of the standard deviation, it calculates all uncertainty, even if you are doing what? You are going to gain. Yeah, so that's basically about that is a summary of standard deviation. Uh, Understanding of standard deviation. This is just a repetition of all what I have explained. Okay, this is that is a summary of that is of everything which I have summarized. You can always go and check that. Then let's come to covariance. We'll talk about covariance, and then we'll talk about correlation. Let's start with covariance. Who can define for us covariance? My good people, someone to define covariance. What is covariance? And don't just read this, because definitely I will need a deeper maybe explanation. Like, what is covariance? Someone? We have very many, that is people who are already on intermediate level in statistics. So it is your time maybe to prove. Yeah, it is your time to prove that you are really good. So it's your time. It's your time. Someone.
Okay, let me give it a try.
Of course, I love people who try.
Okay, when you talk about covariance, it measures the degree at which one variable changes in relation to another variable. Like if one increases, the other variable can either increase in the same direction or uh, go down. So depending, it is just a degree of
Change.
change.
Okay.
Yes.
All
Yeah.
right. Okay. Yeah. Good. That's a good trial. That's a good trial. So basically, let me just make it quick. Basically, covariance shows us the joint variability of two variables. Here, we are talking about two variables. Okay. Covariance, we are talking about two variables. Okay. Or two assets, depending with what you need. And that is covariance gives us a directional relationship. It gives us a directional relationship between two variables. Okay, or it shows us now the degree of change. Of course, in that, the value of that is covariance is the one which shows us the what? The degree. But the major, that is the major, what can I say? The major thing that covariance shows us, it is the directional relationship. Okay, and one thing I want us to know is that the value of covariance can range between infinity, that is negative infinity, to infinity. It can range from negative infinity to infinity. Unlike in correlation, where the value of correlation ranges from negative 1 to what? To 1. Yes. Okay. Yeah. So meaning you can get a value that is another, let's say a value of covariance like let's say like 1,000. That is 1,000. Okay. You can get even negative 600. Negative here, negative and positive here, they are directional. Okay, they are directional. Like for example, if we have a positive values, then it means that the two variables are moving in the same what? They are moving in the same direction. Okay, they are moving in the same direction. Like for example, let me give you an example. We have that is the price of house. We have price of house and the what? And the size of the house. And the size of the house. What happens? We know that as the size of the house increases, so does the what? So does the price. Meaning these two variables are what? Are have a direct, that is a direct, or they are directly proportional. Okay? Meaning they are moving on the same direction. An increase in one will trigger an increase in what? In the other. It's the same as the way we do, that is, we pay for the rent. Like, for example, let's say we have someone living in one bedroom, okay, another one in two bedroom, okay, and another one in bed bedroom. Of course, we know as the number of bedrooms increase, so does the what? The rent paid to that house, depending with also the location. Okay, I'm assuming that these houses are within the same location. Okay, because maybe that's my major assumption, because you might find that one bedroom in let's say in in location A, it is what, it is 20,000. Okay, and you find also in location maybe B, the same one bedroom is what, it is 8,000. Okay, it is 8,000. So you can see it depends now. A location, it's another factor, but I'm assuming that we are we are talking of the that is the same location. Okay, so one variable, that is the size, and then the second variable is the what, it is the price. So increase in one will lead to decrease in what, in the other. Okay, yes, so that's a type of positive, that is relationship. Then we also have a negative relationship. Okay, whereby like uh, increase in one that is increase in one variable will trigger a decrease in the what, in the other variable. Like maybe you can go and try and check one example. Okay, or that maybe triggers increase in or change in one variable will affect the other variable in the what, um, in the opposite way. So let's do a deep dive and see what covariance is. So covariance measures directional relationship between the what, the assets of two, that is the returns of two assets. For my case, it is this is more of a financial what, financial definition. But a general definition, it's like it is a directional relationship between what, between two variables. Then we have a positive covariance, which means that the assets they move together, while negative covariance means that they move inversely. They are inversely proportional. Okay, when one is increasing, the other one is decreasing. Yes. So let's go to that is covariance is calculated by what? Is calculated by analyzing at returns, that is surprises, that is standard deviation from the expected what, return, or by multiplying the correlation between two random variables by the standard deviation of each variable. But don't worry about that, we shall check or we shall learn more of the formula when we'll be doing the practicals. Then any question before we can maybe go to that is some takeaways for covariance? Any question maybe? And before even we can go to the takeaways, before we can go to the takeaways, we can try and understand what, the covariance. So covariance, we've said that evaluates how the mean values of two random variables move together. Like for example, if stock A returns moves higher whenever stock B returns moves higher, then they have what, the same relationship, or we have the same relationship. And in case one variable or one stock reduces, then also the other one will what, will decrease. Then in that case we usually say that they have what, a positive covariance. And in finance, covariances are calculated with to help diversify security holding. So with that, definitely you will see like what factors maybe affects what, affects maybe a certain security. Okay, so if a certain factor affects your security in a positive way, then it will be better. If the other one will affect maybe in the negative way, then also it will depend. It will depend with that is you with your diversification what strategy. So that is covariance equation is used to determine direction of the relationship between two variables. In other words, whether they tend to move in the same or in the opposite direction. Then a positive covariance between two variables indicates that these variables tend to be higher or lower at the same time. Like in other words, a positive covariance between variables x and y indicates that when x is higher than the average, then at the same time y will be what? Will be higher than the average, and then vice versa. Okay. Yeah, so that's I think we've really explained more about that is the positive and the negative covariance. But what I need us to do is now to try and see what is the difference between covariance and variance. What it is the difference between covariance and variance. So covariance is related to variance since it is a statistical measure for the spread of the points in a data set. So both variance and covariance measure how data points are distributed around the calculated what? Around the calculated mean. However, variance measures the spread of data along the single what? Along the single axis, while covariance examines the directional relationship between what? Between two variables. Why? Because here we are talking of distribution between what? Between that is from the mean. Okay. But when now we are talking about covariance, we are talking about directional relationship between two variables. Here we are talking of two variables, and we want to see that is their relationship. Like if that is let me reframe that. Like it tries to show us the behavior, that is behavior of one factor or behavior of one variable, what contribution or what impact will it have to the what? To the other what? To the other variable. Basically, that's what we are trying to mean. Then, what does covariance of zero mean? Because we said covariance runs between negative infinity to infinity, meaning we have zero in between. Okay? So, what happens? What does it mean when we get a covariance of zero? Basically, it means we don't have no clear directional relationship between these two variables. You don't know which direction, okay, these two variables, maybe, or one variable it's moving, okay, compared to the other. So, a covariance of zero indicates that there is no clear directional relationship between the variables being measured. In other words, a ix value is equally likely to be paired with a high or low value for what? For y. Like for example, if maybe um, like let's say a high value is equally to be paired with what? With a high or low value. Why? Because with this we don't have any clear, okay, we don't have any clear information about the direction. So you might find yourself what? Pairing all that is of your values or variables to be what? To be the same, because you don't know what their impact to each other. So some takeaways, then I allow you to ask questions. or to contribute. So covariance, we've said it is a statistical tool. We've said it is a statistical tool that is used to determine the relationship between the movements of two random variables. Okay, when the two stocks tend to move together, they are seen as as having what? Positive covariance. That is, if they are moving to the same direction. Okay, like when one is increasing, the other one is increasing, or when one is decreasing, the other one is also decreasing. So with this and this, we are talking of positive what? Positive covariance. We are talking of positive covariance. But if one is increasing and the other one is decreasing, then we are talking of what? The negative covariance. We are talking about negative covariance. Okay, so covariance is different from the correlation coefficient, a measure of the strength of the that is correlative relationship. So covariance is a significant tool in modern portfolio theory as it is used to ascertain what securities to put in a portfolio. Then risk and volatility can be reduced in a portfolio by pairing what? The assets that have negative that is covariance. So if we have or if our portfolio has assets that have a negative covariance, then it means we have already diversified what? Diversified that is our portfolio. Why? Because in case of an external factor which might affect one asset, it won't affect all what? It won't affect all the assets. That's the investor is said to enjoy. It is said to enjoy uh, the benefit of diversification. All right. Now I need questions. I want to hear questions from you. Questions? Okay. Then does silence mean we are all good? Does silence mean we are all good? Okay. I think we are all good, and we can today we can proceed to a break of 10 minutes, let's say 20 minutes. We can proceed to a break of 20 minutes and then come and do that is correlation. We have how many slides? We have one, two, three, three. We have some that is we have some almost that 46 minus 37, almost 9. We still have 9 slides to go, so we can have a break of 20 minutes. So let's be back at 9:20. So you can grab a cup of coffee as we wait to, yeah, to join at that time. Okay. All right. Thank you. Thank you.